1.10 limits to infinity. What is an infinite limit? We've already talked about it. An infinite limit is a limit as x goes to infinity. What it's saying is it's describing what the function does as it goes to the right in this case. If it was negative infinity, it's what it's doing as it goes to the left forever. And there's three possibilities here. The first possibility is that you have matching degrees. And remember, degrees is determined by the highest exponent you see. So we have an x cubed and an x cubed. When they match, the rule is to divide the leading coefficient. So you would have 5 divided by 10, and you reduce it down to a half. So this limit, as x is going to the right, that means there's a horizontal asymptote here at y equals 1/2. Okay, so you better put that here somewhere in your notes that you're going to divide the leading coefficients. Let's see. Okay, the second case, if it's bottom heavy is what I called it, is saying like this has x to the first, and this has the highest exponent is x to the third. So that it's got a higher power on the bottom than it does the top. In this case, it's always going to be zero. Always, always, always. So if it is bottom heavy, it's automatically got a horizontal asymptote at y equals 0, or the x-axis. And you should recognize these rules. This is the same thing that we used to find horizontal asymptotes of rational functions last year. Okay, and then the third case is if it's top heavy. So now we have where it's an x cubed over an x to the first. This rule is when we had slant asymptotes. But if we have a slant asymptote, what that means is this end actually is going up forever. So the limit, as we're going to the right, is it's going up to infinity. But they're going to want us to put that it does not exist. So because it has a slant asymptote to where this end is not going to level out and flatten out to where it has a horizontal asymptote, then they want us to put that it does not exist on this lesson. Okay. The next couple, or the next one, is going to specifically want us to find, well, is it going up to positive infinity or is it going down to negative? And we'll talk about that later. So let's try that with our rules. It says determine each limit in simplest form. If the limit is infinite, it does not exist. So on number 1, find the highest power. I see x cubed and I see x to the 4th. That makes this bottom heavy. If it's bottom heavy, it's just my normal fraction where it's going to equal 0. And you could graph that and see that it has a horizontal asymptote of 0. All right, and number 2, this is in factored form. So the only thing we'd have to do is think about it, well, if I FOILed it, what would my highest degree be? And I don't need to take time to FOIL the whole thing, because first terms are just going to be a constant. Look at the outers squared, inners cubed. I want to take this times this, and I get a 10x to the 5th power. Then on the bottom, I just want to multiply these two to get what the highest power would be. That would be negative x to the 5th. Okay, so they are matching, and when they're matching, I'm dividing the leading coefficients. So that would be 10 divided by negative 1, which is negative 10. That would be my horizontal asymptote. Okay, I'm going to let you try number 3. When you FOIL what you need to out, you get a cubed over a squared, and it is top heavy, so this is automatically does not exist. It would have a slant asymptote. Onto the back side, or the next page, we got type 2 limits to infinity with square and cube roots. The only difference about this is you have to simplify any square cube roots first to figure out what your degree of your polynomial actually is. So on number 4, we would want to use the highest powered term, and we would take the square root of 64 and then the square root of x to the 9th power which remember that we write it as 9 halves because our index here is a 2 over 10 x to the 4th, which is the highest degree in the denominator. So think about 9 divided by 2, that's really 4.5. So which power is heavier or bigger is the top. So when it's top heavy, this is automatically does not exist. All right, number 5, we have a cube root this time. We're going to use our biggest power. So we would take 6 divided by 3, which is x squared. And then on the bottom, I'm going to use my 5x cubed. So it's bottom heavy, which means that it automatically is 0. And then number 6, I've got my highest power here. So it'd be the cube root of negative 64 is a negative 4. 6 divided by 3 is x squared over 10x squared. They match. So I'm going to divide negative 4 by 10. That reduces down to negative 2/5. And then type 3, we've got limits to infinity with logs, powers, and exponentials. Your goal is going to be to try to figure out if the numerator or the denominator is growing faster, because we're always comparing just only one part of the numerator to one part in the denominator. Oh, went too far. I went ahead and graphed these to save us some time. So the first thing I want to show you is a log, and I graphed f of x equals natural log of x. This is the parent function. They grow the slowest because we're looking as x goes to the right. Do you see how slow this line is increasing? Versus powers, they're kind of in the middle here. Okay, here's x cubed is what I chose, cubic function. Look at the end, how steep it's growing, or how much of an angle it is. So it's going up faster than what this is by a lot. And then exponential, they grow the fastest. And exponential is when you have x as a power. So you see this going like this. When you change this base, it gets steeper and steeper and steeper. So I'm kind of looking at this becoming almost a vertical line, right? So this is almost horizontal. That means it's slow. This is kind of angled in the middle. And this becomes almost vertical. So that means it's growing the fastest. So that's what you're trying to decipher and find out. Okay, so number 7, it says, which statement best describes each limit shown below? Well, we're trying to figure out, is it 0, is it a value, or is it does not exist? In the numerator, obviously I only have powers. So my biggest power is x to the 33rd. And then on the denominator, which is bigger, a power or a log? Well, we said powers beat out the logs, so I'm going to circle this one. I have matching powers, so my rule was divide the leading coefficients, which is -1 divided by 1, which is -1. So it's easy as long as you can remember the different rules. All right, and number 8, we've got e to the x, and remember e is approximately 2.7 something. It's like pi, it's an irrational number. And then we have plus something to the 67th power. Now, this seems big, but we already said exponential things grow the fastest. So this is faster, and then all we have on the bottom is natural log of x, which we said natural logs or logs are really, really slow. So this is top heavy, or this is growing the fastest. So when it was top heavy, we have a does not exist. And then number 9, we have only one thing on the top, and on the bottom we have a natural log of x times a 6e to the x. So you're kind of looking at it as a whole, but again, this e to the x power is way bigger than this, so it's bottom heavy. And when it's bottom heavy, we said that it's going to go to 0.